So let us start our today's session on integrating factors. So I think that what is the purpose of integrating factor and why we are using that for a differential equation is clear to everyone. Am I correct? Say right. Exactly. To convert non-exact differential equation into exact, we find a function called integrating factor, so that by multiplying the given differential equation with the integrating factor, it becomes exact. Yesterday I have given 5 methods or formulae. Let me write them again. 1 by mx plus ny, 1 by mx minus ny, 1 by n into dou m by dou y minus dou n by dou x, 1 by n into dou n by dou x minus dou m by dou y, and finally x power h into y power k. Now I am going to take the problems one after the other so that we have a discussion. Whatever the formula we are going to use, the procedure is same for each and every formula. Okay, how to evaluate the problem? So let us go with the first problem. Solve the differential equation x square y dx minus of x cube plus y cube into dy equal to 0. So please take a note of that. After noting, inform. So from the given problem, comparing the given differential equation with m dx plus n dy equal to 0, we have m equals to x square y and n is equal to minus x cube minus y cube. So I can say that it is a non-exact differential equation because dou m by dou y is not equal to dou n by dou x. So you have to evaluate the two values and you have to mention that these two are unequal. Okay? All of you accept for that? Right. Now, whenever you found that the given equation is not exact, so first of all you need to check among the 5 formulas which one is suitable. If you want to use the first one, the criteria for the first one is it must be homogeneous. So apart from the symbol, consider the total power in each of equation. So here the total power is 3, the power is 3, the power is 3. So each term in the equation has equal power, in other words equal degree. So it is a homogeneous equation. So here we write that given differential equation is a homogeneous differential equation. Now evaluate the value mx plus ny. So please tell this value to me on calculating. What is the value of mx plus ny? I think you are doing along with me. Say. Yeah. the value is minus y power 4. Since the value is existed, it is not equal to 0. So 1 by mx plus ny, nothing but minus 1 by y power 4 is the integrating factor. Now, we are going to multiply the given equation with this value. So, multiply the given differential equation with integrating factor. So, I will write the value straight away. Earlier, I have calculated dou m by dou y and dou n by dou x, and I mentioned that also. I left that part for you, right? And I asked you, am I correct or not? So you have to evaluate both dou m by dou y and dou n by dou x. If the value is unequal, then you have to mention it is not exact, then you have to go with the procedure. Fine? Right. So if you multiply with this value, it is minus x square by y cube into dx plus x cube by y power 4 plus 1 by y of dy equal to 0. So on multiplying with integrating factor, this is the thing. Now what happens? Since you are using the integrating factor, if you consider the partial derivatives, let us give the name that m1 and n1, this will be equal automatically. So there is no need to verify them further. However, you can calculate the values separately and you can show that dou m1 by dou y is equal to dou n1 by dou x. So it has become exact on multiplying with this function. Agreed? Then let us go with the usual procedure because it has become exact. So go with the integration part. So integral m1 dx, you are doing the integration with respect to x partially. So here 1 by y cube is a constant. X square integration is x cube by 3. So minus x cube by 3y cube is the answer. And for the second one, integral n1, terms not containing x of dy. If you consider this part, this is n1. Among the two terms, this is the term which do not contain x. So I consider the value only 1 by y dy. The integration is log y or log mod y, whatever you consider. So the general solution is given by joining these two. So minus x cube by 3y cube plus log y equal to the constant c. This is the solution. So any queries for anybody in this approach? Where to use mx plus ny? Say. And I will say one thing that here I have used the first method. For doing the integration of m1, I do the terms only x, y value is treated as constant. In n1, I have chosen terms not containing x. However, if you want to do with the standard procedure, what is the standard procedure? For doing this thing, we go like this, integral m1 minus this solution partial differentiation with respect to y of dy. So differentiate the solution with respect to y partially and subtract the value from n and check whether you have achieved 1 by y or not straight away. Please check that. The same value will come as it is 1 by y again. So apart from doing this type of integration, it is convenient to choose like this. Okay? Clear to all? If M1 and N1 again exact property don't satisfy, that case won't be possible because you are choosing the integrating factor by default. So these formulae are standard. Whenever the given equation satisfies the criteria, it acts as an integrating factor, so it becomes exact. However, to satisfy your doubt, you are again calculating the value of dou m1 by dou y and dou n1 by dou x, and you can check the exactness if any small doubt is there for you, apart from doing integration straight away. So it means that the procedure which you have chosen is incorrect, so go with the other formula. But that such case won't happen. See, if you want to do mx minus ny thing, the criteria is the given equation should be in the form, or you should be able to write in the form y into some value dx plus x into some value dy equal to 0. If it is there and non-exact, obviously this will be the integrating factor. You can apply that without any hesitation. So if you straight away choose the same formula for the given thing, it may be the integrating factor. You cannot say, because for homogeneous you are using this formula, for this type of notation you are using this formula. We are fixed with the methodology, but we didn't try the same formula for this kind of equation earlier. That is the problem. Okay? Are you getting the logic here? What I am saying? Exactly. See, whenever homogeneous case fails, then only we go with the second formula. Because taking common is not possible for the second term of the given equation. So straight away we cannot apply this method for that. So it will not be the integrating factor. 1 by ms minus ny. Now what happens if you are able to take common, then I will say that the equation will be homogeneous and in the required form, so it will have two integrating factors, 1 by mx plus ny and 1 by mx minus ny. The two things are possible here. Fine. It is a possible case because integrating factor is not unique. An equation will possess more number of integrating factors. The only thing is you are making that as exact by means of a formula. That's all. Right. Yes. Third case, fourth case, fifth case, everything is possible. Please understand one thing, that you are evaluating the formula one after the other by a specific procedure. Apart from using these two, right away you can take whether this condition satisfies or not, this condition satisfies or not. If these two are satisfied, you can take that function value as integrating factor without any doubt. So the intention is integrating factor is not unique. We will pick up the convenient one as per the procedure described. That's all. Agree to all? Right. So we are using the first formula whenever the given function is homogeneous. And we are using this formula when the given function of this form. So if everyone is clear with the first module, I will take one problem considering the second one. Shall I? So here my intention is I will randomly take the convenient problems for each of them. Then I will give you a list of problems for your daily test. So practicing more and more, which gives you a good idea. Because ODE is very easy. It only based on the practice. So let us go with the second problem. The second model, I say. So for this is my problem. Now, even though the given problem is not written like this, the problem will be posed as even though the problem is given in this module, by taking the values common like this, we are going to rewrite in this way. Fine. Now, if you compare the given equation with m dx plus n dy equal to 0, so this is m and this is n. Obviously, you can verify that dou m by dou y is not equal to dou n by dou x. I think you can do the partial differentiation on your own. Accepted? Right. So I am not writing that part again. It is because it is known to everyone. Is it necessary for you to write the partial differentiation? Okay. Now what happens? If you compare the terms, here the power is 1, here the total power is 3. So straight away we say that it is not homogeneous. Since it is possible to write the given equation like this. So what is the general form? Y into some function of xy into dx plus x into some function of xy into dy equal to 0. This is the general form. Whenever the given differential equation we are able to write in this way, in such cases, this is the integrating factor. So straight away, we consider the value of mx minus ny. So could you tell the value on calculating that? I say that it will be minus 2x square y square. Please check on that. So, since the value is existed, 1 by mx minus ny means 1 by this value. That is the integrating factor. So, we are multiplying the given equation with this value minus 1 by 2x square y square. Can I write the value straight away on multiplication? Fine. So if you multiply that, you are going to get the value as this is the value. Please check on that. So if you do the problem simultaneously with me, then you can have a better idea compared to usage of the formula. So on multiplying the given equation with minus 1 by 2x square y square, that should be the value. So if everyone confirms that, then I go further. Right. So this is m1 and this is n1. Please understand that verifying the partial derivatives at this part is up to your concern. Whether you can show that dou m1 by dou y equal to dou n1 by dou x, so it is exact. It is up to your choice. So straight away we can do the integration in examination point of view. So integral m1 dx, if you consider the integration partially with respect to x, so here 1 by 2y is constant, 1 by x square is there, integration is minus 1 by x, so here you have plus, so it will be 1 by 2xy, and here plus 1 by 2 into log x. This is the integration value. And if you go with n, terms of n1 not containing x, dy, which is nothing but integral. Among the two terms, we consider only this value because the first term contains x. So this is minus 1 by 2 log y. So joining the two solutions, you will have the general solution of the given equation. Please check that. If any queries, you can ask. Accepted all the solution part? Any queries, please? Now I am going the next module, so I am going with this. So just hold on a second. I will pick the problem which gives a good idea. Please note down that, and you can verify whether it is exact or not. You please check on that. So here m equals to minus of x square plus y square plus 1 and n is equal to 2xy. And it is evident that the given equation is not exact. Accepted? Now see, if the same problem is given in the exam, which formula is most applicable there? So first of all, you check whether each term possesses equal power or not. Here the power is 2, power 2, power 2, here power is 0. So the homogeneous criteria is failed here. So first formula is not applicable. Again, in n you have to common x. It is possible to common x here. In m you have to common y. So it is not possible to common y in each and every term of it. So the second formula is also not applicable here. Are you getting the ideology here? How I am cross checking which formula is applicable at this position? Say yes or no. Now here I am left with two things, 1 by n into and 1 by m into. However, I am choosing the problems at random as per the problem formulas I have written here. So this is the integrating factor for this problem, and in exam you are going to verify for the two things. So you can start with 1 by n into this one or 1 by m into this one. You can start with any one formula. So this is the typical problem in exam point of view, because you don't know among these two which one will become the integrating factor choice. So you can start with either of the thing, either this or this. What is the objective here? If you are starting with this one, on evaluating the result, it should be a function of x or a constant. Similarly, here also, if you evaluate this whole term, the result must be a function of y or a constant. Then e power integral, that value is nothing but our integrating factor. Is my voice clear to everyone? Say. Yeah. Now, if I start with this one, 1 by n into, so 1 by 2xy into dou m by dou y minus 2y minus dou n by dou x 2y. So this will be accepted. Now, for our convenience, you can do with this thing also. Am I correct in writing that? Please check on that. Yeah. Now see, if you use this formula, the output contains two variables. You are not getting a single variable function. So it is not useful. If you have used this one, the output is a single variable function. It is containing only x. So I can pick up this thing as my choice. Are you clear now? What is to be taken in exam? So you are going to evaluate the two things in the rough, and you are taking the function which gives a single variable, either function of x or function of y, otherwise a constant. Sometimes if both things are happen, that won't happen actually, you can take either of the thing. So what will be the corresponding integrating factor? This is nothing but a function of x. Say integrating factor is e power integral f of x dx. So e power integral minus 2 by x dx, this equals to x square, 1 by x square. Please check on that. Accepted? The integrating factor value. So minus 2 log x, nothing but x power minus 2, so 1 by x square. Now, with this integrating factor, I am multiplying the given equation with that. Any queries for anybody with this integrating factor part? How to calculate or how to evaluate? Stay. To anyone? I think all are clear with this. Any doubts? Then please respond. Fine. So, multiplying the given equation with integrating factor, that is 1 by x square, so it will be 2y by x into dy minus of 1 plus y square by x square plus 1 by x square into dx equal to 0. This is m1 and this is n1. So it becomes exact automatically. However, you can verify that. So straight away, I will go with the integration part. So integral m1 dx with respect to x I am doing. So the value is minus of, for this is x minus y square by x minus 1 by x. Accepted? Please check the integration part. I think all of you are well versed with the integration formulas, right? I hope so. Fine. And coming to the second part, second integration, I say integral n1 dy, terms which do not contain x. So this will be integral minus of y square plus 1 dy. So if you integrate the value, minus y cube by 3 minus y. So we add these two solutions and put equal to c. This is our general solution. This answer plus this answer equal to c is our general solution. Okay? So this is the conclusion of that problem. Here, n1 is, okay, just hold on a second. Sorry. So, terms of n1 of dy, here it is just 0. Because here in n1, y terms are not individual. So the solution is 0. So the final solution is minus x plus y square by x plus 1 by x equal to c. That is the final solution. Fine. I will write here. This is the final solution. So since y terms are not there individually, the terms will be taken as 0 dy. So the final answer is 0. Clear to all? Now tell me, is it necessary for you to take a problem on this next method, 1 by m into something? If you know the same phenomena applicable as earlier. So we are just taking, if this case is not satisfied, you go with 1 by m into, the output should be just a function of y. Just like 1 by y square, y cube, like that. E power integral, that value dy is integrating factor. However, if you are interested, I will take one sample problem on this thing also. Shall I? Fine. So the next problem I am going to take as 2x square y minus 3y square of dx plus 2x cube minus 12xy plus log y into dy equal to 0. It is e power integral. So first you are evaluating this whole thing 1 by n to something. You will get a function. So e power integral f of x is the integrating factor. So if you evaluate 1 by n into dou m by dou y minus dou n by dou x, the whole thing should be a single variable function. Then for that result, you are doing e power integral that function value dx. Here, right? Thank you. So I think I am doing a little slow because whoever are doing the problems for the first time, it will give ample time for them to cross check. Agreed? I am not moving at a fast. Fine. So coming to this thing, you can easily cross check. This is m, this is n. However, we go for partial differentiation. Dou m by dou y. This is 2x square minus 6y. Dou n by dou x. It is 6x square minus 12y. Accepted? And it is a non-exact differential equation. Now coming to evaluation, please check. In the first term, the power is 3. In the second term, the power is 2. Powers mismatch. It is not homogeneous. So first formula is not applicable. And coming to the second one, we should be able to common y here. In the two things, you can common y. Here, are you able to common x in each of these terms? Say, not possible. So second formula is not applicable. Then you are left with the remaining two. So straight away you can do with this, you will get a function which contains two variables. You can easily cross check that. So it is also not applicable. Now I am going with this one. 1 by m into dou n by dou x minus dou m by dou y. So 1 by m means 2x square y minus 3y square of dou n by dou x minus dou m by dou y. So terms get simplified. So on simplification, you can say that the value is 2 by y. Here you can common y, the other things gets cancelled. Okay? So you please check on that. After that you give me your reply, then I proceed further. If everyone is clear with that function. 2 by y, how it came? Yeah, I think everyone is agreed with that. the cancellation part? Fine. So what will be the integrating factor there? Integrating factor is equal to e power integral 2 by y dy. So e power 2 log y. So it is y square. So you have to multiply the total equation with y square. So on multiplication, you will get the value as this is the value. Please check on that. On multiplying with integrating factor, that is y square, that is the possible equation. Agreed all? Right? So let us do the integration. This is m1 and this is n1. So integral m1 dx with respect to x. So this is 2y cube into x cube by 3 minus 3y power 4 into x, the integration value. And coming to terms of n1 not containing x, it is the value integral y square log y dy. Accepted? Now you can have the formula of integration by parts. I think you can have the formula integral uv into integral v minus integral v into u dash. Or you can use the other formula also, however. So we take u is equal to log y, v is equal to y square. So using this formula, you have log y into y cube by 3 minus integral of y cube by 3 into 1 by y dy. So minus y cube by 3, 1 by y square. Am I correct here? Wait, just hold on a second. Right. Differentiation in second part. Integral v u dash, u is log y. Can you give the value there? Okay, right. Thank you. So the thing will be y cube by 9. Accepted all? Thank you. Yeah. So you can simplify the value further. That is up to you. Right? So joining the two things, we will have the final solution. So joining the two solutions, this and this equal to C, is our final solution. And we have one more method is left there. Now I am going to discuss that. Shall I proceed then? So is there any confusion to apply which integration formula we are going to use in the exam when the non-exact equation is given there? Say. Okay. Now I go with the last method, that is x power h into y power k. When all these four formulae will fail, in such case only we use this thing, x power h into y power k. Please understand that this formula straight away applicable for any kind of non-exact differential equation. So it is a special case, I will say. Whatever the equation is there, straight away you can apply this formula without using any force. But the problem here is simplification takes a little bit time in doing the problem. That's why in majority of the cases we avoid this technique. Otherwise, for every non-exact equation, it is comfortable to apply. Okay. So I am going to write the procedure for this. Now see, suppose if the given equation is of this form, please note down the form. Where the coefficients m, p, n, q are numbers. So if you are able to write the given equation in this form, then you can apply this methodology. X power h into y power k is the integrating factor, where h and k are simply numbers. H and k will be positive, negative, or fractions, whatever may be the case. Other thing is also there. And how to evaluate the value of h and k? For this, a simple formula is there. In the two equations, you simply substitute the respective values, and on solving them, you will have h and k values. So you will know the integrating factor and you can apply the formula. Okay? Are you getting the logic? Yes or no? Fine. Now let us take one sample problem here. So this is the problem. Now, if you rewrite the given equation like this, is it possible to write or not? We check first. So y into So if you compare this equation with this value, you are going to write the corresponding coefficient values. So what will be m here? 1. So you should feel that it is of the form x power a into y power b. You should feel like that. Then I say that a is equal to 0, b is equal to 1. Accepted? Say, are you getting the logic there? Fine. Here, if you compare with this thing, p is equal to 2, c is equal to 2, d is equal to 0. 1 by mx, please understand, 1 by mx minus ny formula is also applicable here. No doubt at all. The same formula you can use here. That also gives the solution. So the thing is, whenever all the above 4 formulas will fail, in that case, we apply this case, x power h into y power k. Because for one differential equation, there will be more integrating factors, not a single integrating factor. Please understand. Clear? Right. And for this thing, I will say, please understand, the power should match. So you are going to take that, since you have written a is equal to 0, b is equal to 1, so I will say that you should compare this thing with n into x power a into y power b. You should compare this thing with 2 into x power c into y power d. So you should compare like that. N is equal to minus 1, a is equal to 0, b is equal to 1. And if you compare with this, q is equal to 2. Now you substitute the corresponding values in these two and cross multiply, you will get h and k values. Why we are using this method? You are asking that, right? Why should we use this? Please understand, in the comparison, what is to be compared there? X power a, y power b. Here the coefficient is n, here the coefficient is m. So the power should match. Those coefficients we should take. So here a is equal to 0, b is equal to 1 means x power 0, y power 1. The same term should be taken here. So that coefficient is n. So sometimes the terms will interchange here. We should take the respective power coefficients. Right. So if you compare the values a plus h plus 1 to 0 plus h plus 1 by m, what is the value of m? It is 1 is equal to b plus k plus 1. So 1 plus k plus 1 by n. N is nothing but minus 1. C plus h plus 1. So 2 plus h plus 1 by p. What is p value? It is 2. D plus k plus 1. D value is 0. And q value is 2. So you cross multiply the values, solve h and k. Yes. So h is equal to minus 5 by 2. K is equal to minus 1 by 2. So everyone can check that, the values. So what will be the integrating factor here? X power minus 5 by 2 into y power minus 1 by 2 is the integrating factor. In other words, 1 by x power 5 by 2 into y power 1 by 2 is the integrating factor. Now see, so far we have solved so many problems such that 1 by x, x square y, these things have come as integrating factors to us. Now here, integrating factor has come with powers as fractions. It is a different thing. Now, did you check that? All of you. So, on solving those equations, you can cross check that. So, if you multiply these two, you will get one equation. If you multiply those two, you will get another equation. Solving them, you are going to get the values as h is equal to minus 5 by 2 and k is equal to minus 1 by 2. Take your own time and check that. So, any queries for anybody in getting the equations? Fine. Then, since you know the integrating factor, you can multiply the equation and do the regular integration. That is common. There is no need to go for integration once again. Accepted? There are no difficult terms are there in the given equation. Yes or no? Anybody else with a doubt in doing integration? Please tell. Agreed or not? Doing the integration part. So, if you are little confused with remembering this form and this equations notation, I will give one simple tip that we are using the last method that x power h into y power k is the integrating factor. So what is the purpose of integrating factor? It makes the given equation as exact. So first of all, multiply the given equation with x power h into y power k. So what happens? It is x power h into y power k plus 2 plus 2 into x power h plus 2 into y power k plus 1 of dx plus 2 into x power h plus 3 into y power k minus x power h plus 1 into y power k plus 1 of dy equal to 0. So, now you equal the terms that dou m by y dou y is equal to dou n by dou x. Now, you compare like term coefficients so that you will get h and k. This is another technique you can follow. So, if remembering the equation form and the formula in solving h and k is difficult for you, you can apply this kind of phenomena also. What you are doing? You are multiplying the given equation with x power h y power k. Consider the partial derivatives, make them equal because this is the integrating factor. Compare the like term coefficients. So on solving the coefficients, you will get h and k as it is. Okay? Are you getting the ideology, what I am saying? Fine. So it is another way around. Why I didn't give this thing, comparing the coefficients after finding h and k, again you are going to substitute the values here, simplification, it takes a little time. Apart from that, doing the previous formula is somewhat convenient. Please understand one thing, that whenever all our previous 4 formulae will fail, in such cases only we use this thing, x power h into y power k. Please remember that. Otherwise, we will never use this formula in examination point of view. So it is an additional package to all. in integrating factors. Okay. So I just want to add a little thing here in integrating factors portion. The main purpose of integrating factor is on multiplying the given equation, it becomes exact. In other words, it is easily integrable, isn't it? Yes or no? So, apart from doing this integrating factor portion, there is one more method called as inspection method or method of inspection. In a simple manner, I say that on observing the terms in the given equation, so we say that are we able to represent the terms as derivative of something? Let me say, if I have given the equation as y dx plus x dy equal to 0. Now, am I able to write this equation as derivative of xy equal to 0? Accepted? Or no? Now what happens? The given equation is written as derivative of something. So if it is easily integrable, if you integrate, integration gets cancelled. Xy is equal to c is the answer. You can do the other way around. You check dou m by dou y is equal to dou n by dou x. Is it exact or not? Do the integration, then also you will get the same kind of answer. So this method of inspection is useful whenever you know the derivative of different functions and able to apply the presence of mind so that on observing the given equation itself, you are able to say immediately that you can rewrite the equation in such a manner that the terms will be derivative of something. So I will list out some of the functions which are already known to you, and I will write one sample problem on that so that you can make use of inspection method whenever it is applicable. Fine. So application of inspection method is purely based on presence of mind. The thought should strike at that examination mode. Okay. But compared to all these integrating factors, etc., it is most useful, the method of inspection. Now I am going to write the list of formula for you. You can take a note of them. Just hold on a second.